Okay, so let's talk about a few practical issues. Then we'll introduce multiple regression, although I don't think we'll get to that this time. And then we'll return to inference after that, okay? Okay, so what does regression output look like, and how do we interpret it? So first, let me show you some regression output from Stata. So I know that you guys are using R, and I'll show you some R output in a second. But most of the regression output I have sitting on my computer happens to be in Stata, and it's probably good for you to see the elements in sort of different statistical packages and be able to sort of figure out what all of these numbers mean. So here on the Stata output, we have beta 1 hat is just listed under this column that says coefficient, and then beta naught hat is at the bottom. Stata always puts the sort of estimated constant, beta naught hat, at the bottom. Okay? Right after the estimated coefficients for sort of beta 1 hat, or for beta 1 and beta naught, we have the standard errors listed. Okay? So those are the estimated standard deviations of the distributions of those estimators. So I was the one who gave LHD3rev its name, and that's just a variable. I mean, I could tell you what's in this regression. This is basically a regression taken from one of my papers where we were trying to explain the sort of ratio of detail advertising in pharmaceuticals to sales, trying to explain that ratio with sort of characteristics of the market, like revenue. Okay, so that's one of our measures of revenue. That's a crazy name for a variable. We called it something different in the paper, but in my sort of crazy Stata code, that's what it ended up being. The underscore const, that's a name given by Stata. So that's basically just saying that's the estimator for the constant or the intercept in the regression. Okay. So the standard errors are listed there, and then we also have, we'll get to I'll point out the t-test in a second, but here are the results for the f-test that I mentioned. So typically, let me just say something. So typically, statistical packages, when they give you the output for a regression, give you a bunch of stuff for free. And one of the things they give you for free is the standard f-test I just mentioned. Okay, so they'll just run it for you for free, and they'll report the results. Okay, so here are the results of the sort of standard f-test. And what this particular f-test says, remember, we want to reject for large values of the test statistic. We want to reject the null that beta 1 is equal to 0 if we get large values of that f-test. Okay? So they performed the f-test, and they also gave us the p-value. So last time Esther defined what the p-value is. That's basically the probability that, I hope I don't screw up this verbal definitions, the probability that it's the point at which, if you were doing a size p test, you would reject the null. Okay? So what size test do we usually do? We do 5% tests, we do 1% tests, things like that. Here we have to do a test as large as basically an 18% test in order to reject the null. We're never going to do an 18% test, so we don't reject the null here. Okay? So basically, if you looked up 1.9, which is the value of our F statistic for this particular regression, if you looked up the critical values in an F table, you would conclude that you don't want to reject the null under this case. And that's exactly what the results here tell you. They say, unless you're doing, you're choosing a ridiculously high alpha for your test, you don't want to reject the null. Okay? How about this one, though? For this one, we would reject the null for that beta 1 is equal to 0 if we were either doing, if we were doing a 5% test, If we were doing a 1% test, we would not reject the null. So basically what this F test is telling us is that if we want to do, you know, sort of, a 3, this is the p-value. The p-value sort of tells us the boundary of the size of the test, you know, at which we would reject, okay? Is that clear? And here, we also get this for free every time we run a regression. They perform a t-test for, you know, basically the hypothesis that that particular coefficient is equal to 0, okay? And we'll talk about, you know, sort of I'll make more precise next time exactly what these tests are. But this is just a t-test for the, you know, for each coefficient being equal to 0. And in this case, we do not, we don't reject the null for either one. I guess down here, we reject the null for this one at 5%.